Why do I need to know this? I need to go take a break.
Hey, Summer. How's that chemistry studying coming along? Do you need any help?
Oh, hey, Atlas. It's coming along, I guess, but, not super well, to be honest. I just don't know why I need to know this stuff. Achoo! Plus, as you can see, my allergies are acting up. I can't even concentrate with my eyes on my nose being all itchy and stuff.
Well, Summer, I actually have something that might just help you with those allergies so you can get back to practicing your chemistry. It's called diphenhydramine hydrochloric acid. Don't worry, it's totally safe.
Whoa, what's that? Sounds kinda dangerous.
It's just Benadryl. It's the active ingredient in your allergy medication.
Oh, okay, well, if it's just Benadryl and you're a trusted friend, then thanks, I appreciate it.
You know, Summer, chemistry can be pretty fun, and it has been extremely useful at making our lives easier. Let me tell you a little story about diphenhydramine. Diphenhydramine was discovered in 1943 by chemist and professor Dr. George Rivershell. Rivershell was actually searching for alternatives to treat motion sickness, but instead he discovered something that worked great for allergies. This antihistamine we now call Benadryl today. Because diphenhydramine worked so well compared to other antihistamines at the time, by 1946, only 3 years after it was discovered, it would be the first FDA-approved first-generation antihistamine marketed. To make this compound, Dr. Rivershell took two molecules, bromodiphenylmethane and dimethylaminoethanol, and reacted them together. Together they produced diphenylhydramine. This type of reaction in organic chemistry can simply be referred to as a substitution reaction. So again, the actual reactions are a bit more complicated, but for simplicity, the substitution in our case requires a nucleophile, a chemical species that likes to form bonds with other molecules by donating its electrons, and an electron-deficient species that we'll call an electrophile. This literally translates to electron lover. Lastly, the substitution reaction requires a leaving group to make room for the newly attached nucleophile. In the reaction Dr. Rivershell performed to synthesize Benadryl, dimethylaminoethanol is acting as the nucleophile, and bromodiphenylmethane is acting as the electrophile, while the bromine attached to the bromodiphenylmethane is the leaving group. When the new bond is formed and the leaving group bond is broken, the final product is Benadryl. To purify the product, after the reaction is complete, it is common to wash the reaction mixture with other chemicals called solvents. Typically, these solvents don't readily mix with the organic reaction mixture, kind of like when oil and water separate. These two layers are referred to as the organic and aqueous layers. With little shaking or agitation, the solvents attract and draw out the impurities from the organic layer without removing the desired product. Once the organic layer is impurity-free, the aqueous layer is drained away, leaving us with our pure product in solution. Chemistry can also help stimulate the economy. For example, by the 1960s, Benadryl sales reached 6 million a year, and by the 1980s, sales skyrocketed and peaked at 180 million a year. Benadryl has so many uses. As you know, it makes a great allergy treatment for humans of all ages, but did you know that it can be given to our pets to treat the same symptoms? It even makes a fantastic sleep aid, and it has even been known to reverse extrapyramidal symptoms, which are involuntary movements in psychiatric patients. Benadryl is an amazing compound that is still widely used today. It's even considered by some clinicians to be better than some of the later generation leading antihistamines on the market. Chemistry is really important and can, has, and will change the world for the better. Even if it doesn't quite make sense at first, keep practicing your chemistry, Summer, because who knows, you might make the next great discovery in the future.